So we're going to talk next about quadratic functions and their graphs. Well, what is a quadratic function, you ask? Well, a quadratic function is a nonlinear function in the form y equals ax squared plus bx plus c. Feel free to pause the video as you jot these definitions down. So a quadratic equation is going to take the form such as y equals 5x squared minus 4x plus 1. It's not going to make a line, but it is going to make a parabola. And a parabola is the U-shape of the graph of a quadratic function. Now it is a function, so the parabola could open down, or it could open up. Now the vertex is the highest or lowest point of a parabola. It's the minimum, the valley, or the hill of the parabola. Now the axis of symmetry in a parabola is the vertical line that divides the parabola into symmetric parts. So given the U shape, this is the line of symmetry. We can fold one half of the parabola over the other, and it's a mirror image. We say a parabola is increasing when its y values are going up. Hence, it would be this part of the parabola. Or, if it looked like this, could be that shape of the parabola. The decreasing part is the other half of the U. It's where the y values are going down. Now, solutions to a quadratic function are any places where the parabola crosses the x-axis. This parabola has two solutions because it crosses the x-axis twice. Now, our goal with quadratic functions is to find some of the key elements of the graph. And there's a lot more that you'll do with parabolas as you move on in math, but we're going to take a look at four graphs, namely A, B, C, and D. Now, if we take a look at the four graphs given, we're first of all going to find the number of solutions that each graph has. This number of solutions is the number of times the parabola touches or crosses the x-axis. And so let's take a look. If we take a look at graph A, there is one solution because the parabola touches the x-axis one time. So we're just going to go ahead and put a 1 there. Now the location of the solution is the x value where the parabola touches the x-axis or crosses it. And so for this, we can say then that the solution is at x equals 0. Now, we're going to move on to graph B and do the same thing. The number of solutions. Well, you'll notice that the graph crosses the x-axis once and crosses it again. Okay, so it's going to have a total of, you got it, 2 solutions. Now, the places where the graph crosses is the graph happens to cross at, it looks like x equals -2. And it also looks like at an x value of 4. Well, let's look at graph C. Notice the parabola doesn't even cross or touch the x-axis. Therefore, we say that the number of solutions is 0, and there are no solutions. And finally on to graph D. Now this parabola opens down, and it has 2 solutions right there. And it looks like those 2 solutions happen at -1 and 3. So 2 solutions, and x equals -1, and x equals 3. Great. The location of the vertex. Well, the vertex is the hill or the valley of the parabola. It's the highest or lowest point. And so all we need to do on each of the graphs is identify on graph A, graph B, graph C, and graph D, the ordered pair that makes the vertex. So the vertex on the first one appears to be the origin. 0, 0. The second one, since it's drawn to scale, looks like it's 1, -9. Graph C appears to happen at -1, 2. And graph D appears to happen at 1, 4. Perfect. Now the axis of symmetry is this imaginary line that goes through the vertex, and I'll draw all 4 of them in. That's the line of symmetry, or as we called it, the axis of symmetry. Now this line is an x equals line. Every point on that dotted line has an x equals for the equation. So the first line of symmetry, or axis of symmetry, is that x is equal to 0. The second one is that x equals 1. The third one, x equals -1. And the fourth one is that x equals 1. Okay. So we've got that all filled in. Now, we have all that information, and so now what we want to do is we want to start taking a look at when the parabola is going up. Well, the parabola is going up on graph A, and I'm just going to shade it in, on that red part right there. The y values are increasing. Notice I start at the vertex. On graph B, on graph C, and on graph D, it's going up on the left of the parabola. Now, in taking a look at these red features that we have here, we want to go ahead and identify the increasing interval. Well, we can say that as when x is greater than 0 on graph A, the parabola is going up. On the second one, when x is greater than 1. The third one, when x is greater than 1. And the fourth one, when x is less than -1. Now, the second thing we want to look at then is we want to take a look at when the graph is going down. Well, this is decreasing. And it's doing that in the purple regions. So basically how we answer this is it's decreasing. We write the inequality the other way. When x is less than 0. On B, when x is less than 1. On C, when x is also less than, but this should be a -1, just in case I missed that on the last one. There we go. And on our final one, when x is greater than 1, and again this last one should be a positive, it looks like there. So graph D should read x is less than 1, x is greater than 1, that's when it's increasing and decreasing. So take a moment and look at our final question and see if you can find the element from the graph that's given to you. So pause this and do the problem that's there. Okay, and away we go. Let's take a look at it. So with this particular graph, number of solutions. Well, 1, 2 places where the parabola crosses the x-axis. The solutions appear to be at x equals -2 and x equals 4. The vertex, which is this point right up top here, appears to be at 1, 9. The axis of symmetry, which goes right on through there, through that vertex, is going to happen at x equals 1. The increasing interval is where the function is going up, and it's going up in this red region right here. So in that region, we're looking at increasing. It's going up when x is less than 1. And finally, the decreasing interval happens on the other side. when the y values are going down. So therefore we could write that as when x is greater than 1. And that, it takes care of some of the specifics of the graph of a parabola, namely the graph of a quadratic function.